This question is for Zach. What if you could power a house with the radioactivity from bananas? Not solar, not wind, not a nuclear reactor, just bananas. That yellow fruit sitting quietly on your kitchen counter. Could you stack enough of them floor to ceiling until your lights flicker on? Until your refrigerator hums? Until your entire house runs on fruit? It sounds absurd. But here's the twist. Bananas are radioactive. And that tiny fact leads to a much bigger story about atoms and scale. Imagine you're holding a single banana. Soft, harmless, ordinary. Inside it is potassium. And a tiny fraction of that potassium is a radioactive isotope called potassium-40. Potassium-40 is unstable. Every so often, completely at random, it decays. When it does, it releases energy. A small burst of radiation. That radiation quickly turns into heat. Not enough to feel. Not enough to see. But it's happening. Every second. In every banana. So how much energy are we talking about? A banana experiences roughly a dozen radioactive decays per second. Sounds impressive. But each decay releases an unbelievably tiny amount of energy. Add them together, and one banana produces only a few trillionths of a watt. That's not enough to power a light bulb. Not enough to charge your phone. It's almost nothing. Now, zoom out. Your house needs about 1,000 watts of continuous power. Lights, fridge, Wi-Fi, fans. To get that from banana radioactivity alone, you wouldn't need thousands. You wouldn't need millions. You would need around 300 quadrillion bananas. That's 300 quadrillion bananas. Picture it. A mountain of yellow stretching across cities, towering over buildings. A continent made of fruit. And even if you could gather them, there's another problem. Capturing the energy. Nuclear power plants work because they use materials that decay incredibly fast, billions of decays per second inside dense fuel rods. Bananas decay slowly, gently, scattered across soft tissue. To harvest their energy, you'd need near-perfect efficiency. No losses. Which is impossible. But here's the irony. Bananas do contain serious energy, just not from radioactivity. Each one has about 100 food calories. Chemical energy. If you burned bananas as biomass fuel, you'd get far more usable power. In fact, a few hundred bananas a day converted efficiently could match a home's daily electricity use. Still ridiculous. But compared to 300 quadrillion? Tiny. And there's a darker twist. If you actually stacked hundreds of quadrillions of bananas together, they wouldn't quietly power your house. They would rot. Bacteria would break them down. Heat would build. Methane gas would form. Highly flammable methane. Your banana mountain wouldn't become a nuclear battery. It would become a biological hazard. Hot. Unstable. Potentially explosive. So, could you power a house with the radioactivity from bananas? In theory, yes. Physics allows it. In reality, it would take more bananas than humanity could ever grow. The lesson isn't about fruit. It's about scale. We hear radioactive and imagine danger. But sometimes radioactivity is just a whisper. Your own body is more radioactive than a banana. The universe is filled with tiny atomic sparks, most of them too small to matter. So next time you peel a banana, remember, you're holding something slightly radioactive, slightly nuclear, but nowhere near powerful enough to light your home. Some energy changes the world. Some barely warms the air. Knowing the difference, that's where the real power is.